I made an archery robot that always hits its target. Well, most of the time. Sometimes it misses and smashes me in the face. Yo, come on. I got this really cheap bow from Target the other day, and in no time flat, I thought I'd be looking like Hawkeye out there, but that was not the case. I kept missing over and over and over and over again, so I started to train. So I began shooting 3 hours at a time. I began scouring the web, seeking resources, studying up on the game, and I came back and shot arrow one more time. And after all that training, I came back, shot one more arrow, and I was still bad. So I did the next best thing I know how to do, and I built a robot. First, I needed to find the target, and this camera can do just that. This camera here is special because not only can it give me the color and vertical height of the target, it can also give me the depth of the target too, using these two infrared stereo vision cameras. Next, I'm going to need to aim the bow, so I need to mount the bow to something that rotates the bow's pitch angle up and down. The bow string needs a way to be pulled back to command different velocities of the arrow on exit. Lastly, the bow is going to need a mechanism to release the arrow when it gets to the right position. I had to design this robot in the computer first, else it wouldn't have came together. Pulling the arrow back, I used a motor attached to this super long release screw I found online. When it was time for the arrow to get released, the servo opened up. The whole bow assembly is attached to a single motor that is working its butt off to change the bow's angle. Here's the final robot. If I was smarter, I took a montage and put it all together, but so the arrow get attached to the little pin right here, is able to get pulled with the lead screw, able to, in the stepper motor right here, is able to bring it back and forth. And when I need it to finally get to its last position and release, this little servo will pull up and release the arrow. And the whole thing is able to pitch with this motor up and down. One thing I don't have is yaw, so it can't aim, but if it's in line with the target, it's able to pitch up and down. And then lastly, we have this video camera that's able to take images of the target, and then it's able to find the distance and height just by their color. And lastly, it's all powered by this Arduino Mega. So this is the part where I try to explain the math behind everything. This is probably more of the boring stuff. This robot, in a way, is similar to Mark Rober's dartboard and stuff made here at Basketball Hoop. But for this robot, I do all the math before the arrows in the air. So I got a different bow. This bow was better because it would constrain the arrow better. The other bow allowed the arrow to go all over the place. First, the bow can be modeled as a simple spring. The amazing thing about spring is that its force is linear with the distance traveled. For a bow, this force is called a jaw weight, and a typical value for an Olympic archer will be 50 pounds at the full jaw length, or the max extension of the bowstring. To see how strong my bow is, I can measure different points at set distances using this force gauge. And after getting all those points, I can use something called linear regression to solve for the slope of the line, and the value of the slope is called the spring constant. Okay, finally, let's figure out how do I hit the target every time if I know the height and the depth from the stereo vision camera. So there's actually a multiple solutions for different initial velocities and different angles. I can shoot it really high and shoot the target down like this. I can shoot it a little softer of an angle like that, like even a really small angle, and hit the target from there. But if I extend the bow to its max velocity, for I have as much impact on the target as possible, then the solution to that problem becomes this. I don't feel like deriving this whole thing. And the initial velocity here is just, I find that through the energy conservation. Now that I showed all that math and setup stuff, let's get to some of the fun stuff. The robot initially was missing the target by a little. Sometimes it will overshoot or undershoot the target just by a bit. After tightening up some loose screws and making sure everything was aligned and tight and fixing my trash code, I was able to start getting some consistent bullseyes. After I was tired of hitting bullseyes on the cheap plastic target, I bought a cheap shirt that had a target symbol and printed on it and had the robot shoot that target. It was slightly off, but it was able to still do the job. Now it's time for all the marbles. I put a toy apple on my head and had the robot shoot it off. This was the hardest one to do because the apple was so damn small.
I got hit in the head several times before this, but after some slight tweaks, it was able to work. If you enjoyed this video, please consider subscribing and leaving a like. I got a lot more videos planned for the future. Also follow me on Instagram and Twitter. I post clips of projects I'm currently working on there. Thank you for watching.